Okay, so one of the things that I would do right off the bat with this one is that I noticed that I have 6 over 4. Can I simplify that? I can simplify that right away, and I'm going to do that. Just the only reason that I'm going to do that is just because I know that I don't have to, but in my answer, you probably would have noticed you could have simplified it a step further. You probably could have taken out a 2, which is no big deal. So if I take out a 2, I get 3 over 2x squared plus 2 over 5x. Now, when we've been talking about, if you think of it in terms of primes, this is 2 times x times x. Okay with that? Now, between those two denominators, what do they have in common? X. So they only have one value of x in common. One value of x. What's left? A 2, an x, and a 5. Okay. So now as I go through each fraction, the fraction on the left has a 2, an x, and an x. What's it missing? 5. Very good. So you get 3 times 5. The fraction on the right has a 5 and an x. It's missing a 2x. And that's going to get me 4x plus 15 over 10x squared. If you did it the other way, where you didn't, if you didn't take out that 2 to begin with, you probably had gotten 8x plus 30 over 20x, and then you would have noticed that all of them were divisible by 2. And that's fine. That's okay. There's nothing wrong with that. You would have gotten the exact same solution. It just, sometimes you can get simplified out. And that's what happens if you don't if you don't simplify out something in the beginning, you might be able to simplify it out in the end. So you'll notice those things when you have everything's divisible by 2. Bless you. Okay. What was the other one you guys were saying? Was it 30 something? Yeah. I'll do 28 and I'll go 32. Yeah. 32. 32, usually what happens with this one is people will mess up the distributive property because the denominators themselves are two specific terms. Okay? There's no monomial parts to it, it's just two terms. So in order for us to get a common denominator, we have to multiply the two of those together. So the common denominator is going to be 3x plus 5 times the quantity x plus 8. Well, fraction on the left needs the x plus 8. Fraction on the right needs the 3x plus 5. So we have 4x squared, x plus 8, minus 10 times the 3x plus 5. So let's see. 4x cubed, 32x squared, minus 30x, minus 50. Bless you. And granted, you could take a 2 out of the numerator, but it's not going to help you with anything. I wonder if they snuck this one here to be something you can do. No, because then you can take out, yeah, it's not going to do nothing. 10, 3x and 5, yeah. Yeah, it's a trickaroo. You're done. Yep. Now, I know, and here's the one thing I'm going to start to kind of lead you towards here. Where are your vertical asymptotes at this? Wow, you guys turn on me rather quickly. No, that would be your axis of symmetry, but you know, I appreciate you at least gave me something that was vertical. So there you go. Where's your vertical asymptote? Where's your vertical asymptote? You can do vertical asymptotes! Where's your vertical asymptote? Which one? Huh? I can't hear you. No.
Set the denominator to 0. Sorry.
You got the horizontal. There's your horizontal. You're right on that one. Where's your vertical?
Come on. Set the denominator to 0.
Huh? I didn't hear you. Now that I can't see the reflections of you guys in the mirror and the glass as you're trying to. You did not.
You like what? I was like, can you hear you? I was like, never mind.
Now remember, that's the negative side because you have to be in the mirror. I love doing that.
Great.
Anyway, so where's the vertical asymptotes here? -8 and -5/3. Now, the reason why I'm asking about that question real quick is because sometimes you're going to get an answer for an equation of a rational expression that's not an answer. It's called an excluded value. Okay? It's we'll talk more about that tomorrow, but it's one of those things. You've actually done it before, but not with this complicated looking weirdness. What else you got? Distributed property on this one. Yeah. There was no factoring involved for the denominators here. It was pretty quick. In this one, you're going to have common denominator. I have an x plus 1, and a 2x minus 3. Well, fraction on the left has the x plus 1. It needs the x and the 2x minus 3. One in the middle needs the x and the x plus 1. One on the end needs the x plus 1 and the 2x minus 3. So this one just winds up being a whole bunch of distributive properties. So it's not that it's going to be overly complicated. You'll just probably mess up a sign somewhere. Okay. So let's see, 4x squared. Into that, it's going to give me 8x cubed minus 12x squared plus 5x squared plus 5x. This is 2x squared minus 3x plus 2x, so it's minus x minus 3. Is that right? Go check that. 2x squared minus 3x plus 2x. Okay. So then we get minus 8x squared plus 4x plus 12. And a partridge in a pear tree. Did I mess up? No, I could have. It was 4x, because even though that has the x in the numerator, it didn't have the x in the denominator. Oh, that's the other thing with some of these things. If you don't write down the problem correctly, it's awesome, isn't it? All right, so let's see. Here's my numerator. I have an 8x cubed, negative 12, negative 20, negative 15. 5 and 4 is 9. All over. And once again, it just looks a lot worse than what it was. Vertical asymptotes on that one. 0, good. Negative 1. We got those off. Again, the reason why I'm asking you those things is because when we get into solving rational equations, which, believe it or not, you've done, you've actually done that problem before. What can't x be in that problem? Negative 3, very good. It can't be negative 3. Now, what would you do to solve that problem? Cross multiply. The reason that you can cross multiply is why? There's a reason why I can cross multiply. What's that? More importantly, it's fraction equal fraction. Okay? If it was 2 over x plus 3 minus 4, or whatever, 14 equals 4, I couldn't do cross multiplying there because I'd have this 14 chucked up. You'd have to do an extra step to it. So yeah, here you would just cross multiply. This would be over 1, so you have 2 equals 4x plus 12. And then work from there. So what's that, negative 10? You get negative 2.5. So there you go. You've done these problems before. This process by which you're setting them up and going for it hasn't changed. They're just going to look a lot uglier. What else you got? How'd you do with the weird ones? I only gave you a couple, didn't I? Yeah. They want to take a little bit more space, really. Take it. See if you can figure this one out. Ooh, exponent rule. Think about what you're saying. It's not a monomial, so you can't just automatically flip. It's a complex within a complex. What does x to the negative 1 mean? 1 over x. Okay. Now, you can't play the war game here because of the addition part. Okay. So what this problem really is saying is, you're going to have fun. 1 over x minus x over 1 over x plus 1 over 3 over x. Which means you're going to have to kind of work through the first chunk of it. Let's make it go. Let me see if I can rewrite this here. So. Now, it's just procedural. Now, if I'm looking at just this, isn't that, let me move this up here, it was x. I'm sorry, I'm just using space, my handwriting's bad. I was waiting. People were like, the ambulance was showing back up. I didn't realize that I write as I go to the right, it kind of descends. I didn't really notice that. It's getting old. It's possible. Let's see if I can keep this my elbow up. Now it's feel bad for your sister if I look like your sister. Self-deprecating humor right there. Anyway, so I'm going to flip that denominator up. So this portion here becomes this. Because it's just x, if you think about it, it's x divided by 1 plus x over x, so I just flipped it. Okay? I just flipped it, multiplied by the reciprocal. So now, going back to the original problem, you've gotten rid of this extra complex fraction thrown in there. And you have now a 1 over x, which is what we started with, minus x squared over x plus 1. I just rewrote it instead of 1 plus x, I wrote x plus 1. All over 3x. Now you're back to a problem that doesn't look that terrible. It just took a second to get rid of that complex within the complex to get to it. All right? It is, but this part, though, What's going to be the common denominator for those guys? And? Ooh, remember, that's a term. X plus 1. So it's x and x plus 1. It's very similar to the other stuff. Yes, it is. I swear to you, it's the same thing. No, look, it's the same. Seriously, it's the same. You have your common denominator. What do you have in common? Well, I had an x, and then I just had the other part. When am I going to use this? This is more of a problem-solving thing. Can you find a way to solve a problem? Pretty much. Anyway, so multiplying the numerator, the fraction on the left needs the x plus 1, the fraction on the right needs the x, so that's why I wrote it as x plus 1 minus x cubed. Divided by the 3 over x. Flip that bottom around. Yeah, this is, so let's see, negative x cubed plus x plus 1 over x times x plus 1 times x over 3. Well, unfortunately, this is rather anticlimactic because you only get to go once.
No.
One grouping of nanananas. You're going to miss the nanananas because we don't do very many of those next semester. Oh, wait. Yeah, we do. Never mind. There's like a week's worth of them. I forgot. Guess what you get to do next semester? Trigonometric proofs.
No.
Trig proofs. Oh yeah, they're awesome. So trig proofs are nothing more than, trigonometric identities. Like sine is, oh, I'm sorry. Sine is 1 over cosecant. Cosecant is 1 over sine. Trig is actually very useful and applicable in the real world. Trigonometry is what really makes everything work. But knowing how to work your way out of it. Sine squared plus cosine squared equals 1, in case you're worried about that. Yeah, we'll get there. So what I would like you guys to do tonight, and I didn't get a chance to post it yet this morning. I'm going to post up 2 PDF worksheets of just more simplifying stuff out. And we'll put it all together. We'll collect all of it tomorrow. No, we're just going to do maybe like 5 or 6 of them on both pages here. So let me see. This is there's 2 parts here. One is going to be a B worksheet and one's going to be a C worksheet. So we'll do 8, 9, 12, 13, 14 on the B. Then on the C, let's see what we got on that one here. And I'll put, like I said, I'll post these through here. What are the same problems? 8, 9, 12, 13, 14 on C. So we'll do 10 problems total. Okay. And if you give me a second, I'll post it, but I can also snap these into the smartboard real quick too. Just put them together, it'll be fine. We'll collect them all at the same time. I'll show you. The worksheets, there's a B worksheet, a C worksheet, and we're just going to do the same numbers out of each problem. Go. at that. I got them all to fit on one sheet. Do you guys just want to take a picture of that, or do you want me to scan that and put that online like that? All right. If you give me a sec, I'll make a PDF of just this sheet and I'll put it online. But I'll leave this up for now. You guys can work through. Okay.
Are kind of ugly.